about what we call the invertible domain of a quadratic. So when we're talking about invertible or an invertible domain, what we're talking about is if we're to take the inverse of some function, which means to reflect it across the line y equals x, if we were to take the inverse of it, would it still be a function or not? Um, and there's a lot of different ways that we can test that out. Typically, we test it out with what is known as the horizontal line test. This lets us know if something is invertible. So if we look at a quadratic here, the first thing we're going to do is actually kind of plot this out. And because it's a quadratic, it's squared, we know that it's going to be this kind of parabola shape, similar to kind of like a U. And when we're trying to plot it, the first thing we're going to look at is the information that's given here in this vertex form. We want to know, is it going to open up like the one I have drawn here? I like to say it's a smiley face because it's positive. Or is it going to open down as because it's a negative one? That is given just by our A term. So just looking here, I see that there's not a negative, so it is a positive. So this quadratic is going to open up. And the next thing I need to know, especially as I'm trying to find this invertible domain, is where is my quadratic on my coordinate plane? And that is given by the vertex, which we can see here in this vertex form. We're going to take this value, and because it's a negative inside the parentheses, we're going to take the opposite of what we see here, opposite inside, and then normal outside. So the vertex is going to be 1, 3. So I come up in my coordinate plane. I'm going to give a general sketch. I'm going to go over up 1 over 1, 2, 3. And it opens up something that looks like this. So this is just plotting my quadratic to get started, plotting what I have here using this vertex form. But here we're talking about this idea of an invertible domain. And I said we can use the horizontal line test to check it. A horizontal line test says, draw a horizontal line. If it crosses your function more than once, it fails. If it fails, that means your inverse is not a function. But what we want here is we want our inverse to be a function. So we want to pass. So with quadratics, we can actually do something that is really cool. And we can edit our quadratic, or what's known as restricting the domain. So I'm going to get rid of the horizontal line for just a second. Oops. So that we can see this a little bit better. Get rid of this x's. And notice, actually you can see what I just did there. We're going to get rid of half of our quadratic. We're going to take this left-hand side and just make it go away. What we're really doing is we are restricting the domain. We're saying, hey, this half over here, we don't want you. You're restricted. You're not allowed to be here. We only want this part. We only want this part. Now if I draw a horizontal line, it only crosses once, so it passes. It passes the horizontal line test. In order to do this, to show it, like I said, we have to say that we're restricting the domain. Well, now my graph starts right here, and this was our vertex, which was 1, 3. So my x values now start at 1 and go to the right. So my invertible domain will be starting at that vertex, which is 1, and then going all the way to the right, which is infinity. Often if we're doing domain, we'll also put in the range. So I can do that as well. The range is bottom up. So now my range is starting at this point of 3. And notice as the arrow is opening up, it's going on to infinity. So my range here is going to be 3 to infinity. And that's pretty cool. This is what we're trying to do. We're now made it invertible. It is invertible because it now passes the horizontal line test. And we only took this half of the quadratic. And that's what we call this invertible domain. So we're saying, hey, our quadratic will pass if we only look at the half that starts at the vertex. And once again, we get that 1 from this vertex form. That is where we were starting from. Um, so we can actually see what this looks like. I've plotted it out on Desmos for us. And you can see over here that I have my function in. We can see that function, it's that x minus 1 squared. But I went ahead and I put that restricted domain. I said, okay, where x is greater than or equal to 1. And it only plotted this right-hand side, and that's that function in black. For the blue one, this is the function of the inverse. So if I worked everything out, this is the equation I would get for the inverse function. And it's plotted here in blue. Notice I didn't put any restrictions on it. There's nothing after the function that says x has to be greater than this or y has to be greater than that. And it only gave us this top half. So whenever we're using a graphing capability such as Desmos or your calculator, it's always going to give us the function. And the function for a square root is just this top half. And that comes from that invertible half of your quadratic. So they're already related together. And that is what we're looking at here. So once again, the kind of quick way to find the invertible domain is just find your vertex and go to the right. So any one that I had, so say that I have y equals 2x plus 5 squared minus 3. If I'm trying to find that invertible domain, I'm going to say, okay, what is my vertex? Well, it's negative 5, negative 3. So my invertible domain will be negative 5 to infinity. It is always going to be, the invertible domain is always going to be the x value of your vertex to infinity. The range can change whether your graph is going up, so negative 5, negative 3, versus if I put a negative in the front, then my graph would actually look more like this, and that would change my range. I'm not going to change my domain. For each of them, the domain is still starting at negative 5 and going to the right. Starting at negative 5, going to the right. That does not change. The range might change, or the range does. For this one, the range is starting at negative 3 and going up to positive infinity because it's going up. Versus this one, my range, when we do range, we actually start at the bottom and work our way up. So here, my bottom point was negative 3 and I went up to infinity. But this arrow says that my bottom point is actually negative infinity. And as I go up, I stop at that negative 3. So notice that if your quadratic opens up or down, will change the order of your range. But for both of them, and the big one here is that invertible domain. That's what we're really most focused on. And that domain is always going to be the x value